today. I attend all of his talks, most of which I can understand. Today, I'd like to share with you a really fun experience I had. I brought slides of the trip. If you have any questions, please raise your hand. Try and interrupt me. See if we can make sure that we run out of time before we run out of slides. And for those of us who are successful at this, I understand there may be something happening afterwards. Murray, is that right?
Yeah.
What's happening afterwards?
It's Christmas rounds, THETA. You're all invited. It's on the 8th floor. So just take the elevator up and just walk straight out of the elevator. There's food, festivities, trees, fun, etc.
So food for those who stay awake. Help you and your colleagues by raising your hand and asking questions. So today I'm going to be talking about real-world cost-effectiveness analysis, and we'll be focusing on a cancer drug. In particular, I've got a bit of a background to the whole story, and then we'll get into the introduction. Before I begin, though, I have to warn you that the opinions I'm about to express are mine. I'm not speaking on behalf of the people I work with or the organizations I work for. These are just my opinions, and I'm sure glad I'm not being recorded. Am I being? Okay, so this is really just my thoughts today before lunch, a holiday lunch. And please don't take it as official position of Cancer Care Ontario or the Ministry of Health or the University of Toronto or St. Michael's Hospital or any of the other affiliations that THETA made up for me. You should know about my conflicts of interest. This grant was funded by the Ministry of Health. They had a drug innovation fund. They said, we're willing to consider all sorts of crazy ideas. And we said, we have a crazy idea for you. So we put together a team of a variety of different people. We had clinical folks. We had methods people. We had policy people. And we basically said to the government, we want to show you it is possible to use administrative data to do a cost-effectiveness analysis. This is data that you already collect. Let's look at the value of what you're already paying for. So we already do this song and dance before we have any of that data. Wouldn't it be cool if we could actually see what we were getting? Is this feasible to do? What numbers do you get? Do they match what we thought we would see? That's what the grant was about. And we needed a whole bunch of people for this team to work. And you might be thinking, why do we need all these people? Well, oftentimes you get a picture of something and you think you're reading the signs correctly. For example, this one says, feed the fish 25 cents. So you may get out a quarter and you get ready to feed the fish. And then all of a sudden, you see something that makes you think twice. It says, don't throw coins in the pond. So how are you supposed to feed the fish 25 cents when they don't let you put coins in the pond? This is why you need a large team. This is why health technology assessment cannot be done on its own. You need a lot of different partners who can help you read the signs correctly. This grant went in early days of the Pharmacoeconomics Research Unit. Cancer Care Ontario invited me to develop and direct a unit. And I said to them, well, how can I help? And they said to me, you should let us know. So I thought, I better study what's going on. I better talk to people. I better interact with great mentors like Murray, and I better get together a team that's going to help me. I should see what the environment is like, and then I'll try to figure out how I can help. So the first thing I studied was the process by which a drug would be funded. So it seemed to me that drug companies or physicians could submit a dossier to a national committee that would make a recommendation after external experts had reviewed the evidence that perhaps came from a randomized controlled trial or perhaps a model that had been made. And as soon as that committee had made that recommendation at the national level, it went to the provincial level. So it went to Ontario's Committee to Evaluate Drugs, and they did the same thing. They sent it out to external reviewers who reviewed it, and their committee, they made a recommendation. And then that recommendation went to the Ministry of Health, and they did this weird thing called a decision, where if they said yes, then money would actually come to CCO. There's a helicopter, I think that's how it works. It flies over CCO. You can see the helicopter. You hear the helicopter. Yeah, I think that's how they're dropping off the money. Anyway, money parachutes into CCO, and then, at least this is my understanding, hospitals that are giving patients drugs then send the receipts. It's paper receipts, right, Suzanne? Paper receipts they send to Suzanne, who then sends them money. So the thing that was really interesting to me is, like, this is where the real world is happening, right? This is the patient who's getting the drug. Wouldn't it be neat if we actually knew what was happening to this person, and perhaps that could be actually influencing our recommendation either at the national or the provincial level? Maybe, in fact, it might even affect the decision. So the goal of this project was to say, based on what we already have, the data we already have, what can we learn about what we're already doing, both in terms of the outcome and in terms of the cost? And you might say, well, it's nice to do research for research's sake. You can publish articles no one reads. But do you ever see drug policy change? Well, in 2008, there was this drug. I'm not going to tell you what it's called. Are we recording? All right. Well, it rhymes with Avastin, but I'm not going to tell you what the drug is called. And in 2008, there were some provinces where it was covered, and there were some provinces where it wasn't covered. Again, I'm not a physician. I'm a health economist, so I'm not sure why it works better if you're by the ocean or if you speak French. But apparently, 1 year later, there was a change in policy. And all of a sudden, some of the places that weren't covering it now were. So this made me think there is potential for change. I don't know if this change came from research or from some other source of enlightenment. But it made me think that there were opportunities for actions to change. So I thought, wow, we could do research and it might be informative and things might change. So now I'm going to get to the introduction of this research study. Before I was giving you context about health technology assessment and cancer drugs in Canada, now I'm going to focus on this study. And this is what today's talk is about. I'll give you a little bit more introduction. We'll talk about rituximab. Why did we choose that drug? I'll share with you how we picked the people we were going to study. We'll talk about some of the outcomes and then the cost effectiveness. Lastly, we'll get to the conclusions. So the whole point of this grant was this notion of real world value for money, and the notion that we could actually use data we had to study this, things we're already paying for, and we could ask, what are we getting? So you might think, well, why do we need value for money? Maybe if this were, say, labeled extra effect, if you have a red pill and a white pill, if you know the red pill is more effective, maybe that's just enough. And that's just fine if you have infinite resources. However, if you have scarce resources, then you might be interested to know if the red pill costs a lot more or a little bit more. So the vertical distance is the extra cost, and the horizontal is the extra effect. And the line that connects the two dots, that's the cost effectiveness. If it's a steep line, that means it's not very cost effective. And if it's a flat line, that means it is cost effective because you're getting a whole lot of extra effect and not that much extra cost. So basically, this is the notion of value for money. You're looking at what patients are getting. You're looking at the extra cost. One of the major limitations we're going to face is that if we're going to use administrative data, there may not be a lot of patient outcomes to choose from. So again, the purpose was to see if this was possible using data that are already being collected. And why might we want to do this in cancer? There are some people who have written that health economists are concerned. I'm not sure why no one else is, but health economists are concerned because the prices of cancer drugs appear to be rising faster. From my perspective as a health economist, the issue is not that the prices are going up. The issue is related to what are we getting for the extra cost. And in this article, he claims not much. So wouldn't it be neat if we could do research and see what are we getting and what is it costing? And the research would actually be after the drug is funded. So these are not hypothetical cohorts. These are just real people being treated by real physicians. In addition to which we would be able to say, if these are particularly expensive ones, we can help understand the value of these investments. So some people might feel that we ought to be doing a randomized controlled trial because that's our go-to option. You know, we always are thinking about RCT as the way to go. And I think that's fantastic. If anyone has extra change lying around and can afford to do one, that is definitely what we should. But I'm a lazy guy, and I'm thinking if someone's already collected that data, say ISIS, maybe we could use what they've already collected. There are very special and important field trials, which are definitely the way to go. But not all of us can be paths or thetas. Some of us just have to scavenge or live off the data that people have cast aside. It's not a pretty existence, but it was one we're not recording this, are we? It's not a pretty one, but at least we could see what we could do with what we had. So there are some people who have some critiques about randomization. They say it costs a lot to do. They say it may not reflect the real world because you have patients doing what they should be doing. You have special physicians who are doing what they should be doing. I'm not going to dismiss field trials or RCTs in this environment, but I am going to say that maybe there's some value in checking administrative data sources and seeing what we can do. And the huge problem will be, I believe, doctors are not randomly giving patients drugs. You may disagree, but if they aren't giving people drugs randomly, then it's possible it might be difficult to find a control group. This is going to be an issue we'll struggle with later on. But it's not like it's all dark. If you want more details, say you're having trouble sleeping or something like that, you can go to the internet and you can find an article that describes this in extreme detail. This is the beauty of an online journal. You can put in tons and tons of things, and you can see all of the wonderful people who helped produce this research. So this is in a journal called BMC Cancer. It has all of the details. I will refer you to this article if you ask me really difficult questions. All right. It also will tell you that this was funded by the ministry, and we did some things that hadn't been done before. I'm about to start on the methods, but before I go there, does anyone have any questions? Okay, let's talk about how this was done. First, we had to figure out what drug we were going to study. Remember those large groups of people who were on the grant? We needed to talk to the clinicians and say to them, what do you think is a worthwhile drug to study? So we don't want to study something where the clinicians go, oh, not interesting. We also wanted to talk to the policymakers, because if we're going to do a study that they're going to pay attention to, wouldn't it be great if they say, oh, that's something interesting? Then they may be more likely to pay attention to it. Now, the third group we had to deal with were the researchers, those biostatisticians who worry about things like sample size and will we be able to see enough action happening. If we pick a disease where it takes an awful long time for something to happen and we only look at 1 or 2 years, we'll never see anything happening. So we needed to make sure all three groups were happy, and we negotiated to decide upon rituximab. So the first goal of our study was to see if this was even possible. When this was funded, CCO had a data set called the New Drug Funding Data Set, and it didn't talk. It never left CCO, not even with someone to make sure it was safe. It just stayed in CCO. This grant proposed moving it to ISIS. Now it is at ISIS, and this is no reason why it should take years for it to happen. But at the time, this was something that hadn't been done before. We also wanted to try to see if it were possible to use some methods that hadn't been used before. This was a feasibility study that we were conducting. We wanted to then, once the data had been moved, we wanted to study survival and costs. We wanted to see if we could find useful information. And when you do these real-world studies, you can publish 4 different types of articles. Yeah, right? You can look at patterns of care. You can look at clinical outcomes in the real world. You can write papers about direct costs. And you can look at cost-effectiveness analysis. So this could be a very fruitful area to do research in if it were only possible to move this data over. And as I mentioned before, the data has moved. The data have left the building. It is now possible for us to think along these lines. We're going to be focusing on cost-effectiveness analysis. And to do that, we needed to have 2 groups, the people who got the new drug and the people who got usual care. So one way to do this is to try to find a disease or an indication where there are a lot of people. Because if you only have a couple people, you have sample size problems, and that's not a good thing. So we were looking at non-Hodgkin lymphoma, and there were 3,000 new cases each year. And it was a disease where there was some morbid outcomes. So this meant that we were going to have enough events happening, enough sample size and enough death going on that we could use death as an outcome, and we would have a chance of seeing differences between the two. We chose large B-cell lymphoma because it was the most common form. Again, we're looking for sample size, trying to show that it's possible to do this. This may not be an optimal strategy if you're looking at rare diseases, but we picked something that would give us a sample size to see a signal if there really were one. That we were comparing rituximab with CHOP to a regimen called CHOP. So I'll be talking about our CHOP versus CHOP. I guess we're getting this from the clinicians. Remember, it's good to have them on your team. They can help us pick a comparator that makes sense to them. So Ontario seems to have funded rituximab at different times for different age groups. One option could have been a contemporaneous control group where after a certain year we look at the folks who got rituximab and look at the folks who didn't. The problem is that the physicians started using this drug as soon as they could. So once it was funded, there really wasn't a group that wasn't taking rituximab. So we had to use the pre-period as our control group and the post-period as our group that got the new treatment. And you can see 3 different time periods corresponding to age. So that was a little bit interesting. And then we needed to make sure there was enough time so that we might be able to see events. Here you can see about maybe 3 years of time. However, it's not possible that everyone is going to die in those 3 years because we didn't pick a disease that had a big enough death rate. So we know we're going to need to deal with looking at survival when not everyone dies, and we're also going to find out that this is going to affect how we analyze costs. So I was thinking, golly, this censored cost thing could be rather complicated. I wonder if we really have to do it. So I'll show you results in terms of what difference it makes. So we've got the group that doesn't get rituximab. These are the folks who got CHOP in the pre-era. We got the group that does get rituximab, or the people who get R-CHOP, and that's in the post-era. Now, if I'm a lucky guy, I can show you the comparison between the patient groups and say, hey, look, they're similar. And this is the one case, I guess, in statistics where I'm not hoping for significant differences. And unfortunately, we find them. The groups are not identical. In fact, they're statistically significantly different from each other in certain areas like age and how much comorbidity they have, and even histology. So now I need to find a way to compare apples with apples, because if I look at it pre versus post, I'm doing apples versus oranges. Not only do they differ in terms of what drug they got, they also differ in terms of the patient characteristics. So we did propensity score matching to try to make the groups the same. So this is after matching, and you can see all of those significant differences went away. So we thought, wow, that's great. Now, at least on the stuff we have chosen to measure, they are similar. There may be a whole lot of other things where they differ, but because the administrative data doesn't collect that, I don't know. But again, if we're trying to show feasibility and is this possible, we're doing the best we can to try to make the case that the two groups are similar. So now I will claim any differences is because one group got rituximab and one group didn't, even though it's possible that there may be some unobserved differences. Yes, Lucine.
So for post-era, nobody received CHOP anymore. Like everybody switched to like R-CHOP.
It is possible that in the post-era, there were some people that physicians thought shouldn't get R-CHOP. They might have been too sick. They might have been too old. They might have been this or they might have been that. So they are really, really, really different. Does that make sense? Other questions? Yes. Hi.
You include the new diagnosed patient, so
I'm sorry?
Whether you only consider the new diagnosed.
Newly diagnosed incidence cases versus prevalent cases.
So we're looking for whether someone got rituximab or not, and we have an indication. And then the claim we want to make is that the R-CHOP people, the CHOP people are going to be at the same stage of disease. It's not like they're really early on and the R-CHOP are really late.
Eligible to get the disease, to get treatment.
Yes. You can see why we need a team. Okay, so I'm about to show you the results. But before I do, are there any questions?
Yeah, I did
Please,
have one.
Eric.
So you're saying that there's nobody who went across the line of eligibility, so they started off just under the baseline treatment, and then all of a sudden midstream this became eligible and they started to switch over. There's no switching over of people from one modality, from the control to the treatment group. In other words, during the course of the study.
I believe, I'm going to use a lifeline here, Jacqueline. The people who did some switching, if they started on CHOP and they switched to art, they would have been excluded.
Okay, I just wanted to make sure.
This is good, thank you. Vidi?
I was wondering if the researchers and physicians and policymakers were aware of what patients were in which group, like during the analysis of the results, or was it like nobody knew, only the researchers knew?
Oh, this is a really, really, really good question. So it wasn't like we went out and we did a study and it was a field test or something like that. We go to ISIS and we say, hey, you know all that data in the Fort Knox vault that you've got?
The data's already there.
Yeah, the data already collected, just sitting there, gathering dust. So we brush off the dust. Yes, Petros.
So what was the period of time that you followed them after the moment that there was a switch? Yeah, here.
Yes.
So the people that they say someone switched in 2000.
All right.
Someone is in 2000 and is in the pre-era shop and is 65 years old.
Sorry, hang on. 60 years old.
Yeah.
And 2000. So
yeah,
here maybe.
Exactly. So this individual, you follow them forward for how long? To see, are you looking at outcomes within a period of time?
I'm going to watch for as long as we can.
All right. So this individual that did not get switched in the post-era,
Yes.
maybe is a different individual in the first place.
Yes. Yes.
So how similar are the two groups in that sense? Even if they look similar in that.
Exactly.
I noticed that you lose half of them in the matching, first of all, on the art shop.
Yes. So what he's saying is, hey, you started out with 2,800.
Yeah.
Where did you hide the other half? I'm interpreting, though, your question.
Or at least I guess the interpretation afterwards has to be for those that they are matchable, those that are similar, what is the difference in the effect?
Yes.
Are these people similar?
Yes. And then the question is, should we, I'm not saying right or wrong, but should we care about the people for whom we can't find a control? I don't mean care as in, of course, we care about them, but statistically, we've got two things that will make these folks different. One, their patient characteristics are different, and two, they got a different treatment. So if I see a different outcome, is it because they're different people, or am I seeing a different outcome because they got a different drug? Furthermore, because I'm doing it in administrative data, there could be some very important clinical things that we're missing. Another reason for field trials. But the purpose here was just feasibility. But yeah, so these are the things that I worry about, keeps me awake at night. And I read my paper and then I fall asleep.
You're kind of mimicking the randomized controlled trial, right? So in randomized, you kind of, baseline characteristics are even. So in a prospective manner, you can do that. But when you're looking retrospectively, this is the best you can do to make the baseline characteristics similar.
Yeah, what he said. So, but the question is, have we missed something? And oh, by the way, the people I just tossed out, are they hiding something? I'm saying they may be, but I have no one to compare them to. So before, no, not you. Yes.
My concern, we had a similar situation with similar study. But
yes.
My concern is that the interpretation from the policy is going to be on the whole population rather than on the matching population. And that's how. That's like how do you translate the knowledge to the policymaker in a way that it's going to be, you know what, this is the limitation of matching. Yes.
Oh, very, very true. So what he's saying is I might be saying after this study, but just imagine that they've read it. This isn't being recorded. So just imagine that they've read it, and then imagine they say, hey, we want you to explain it to us in like one sentence or less. If I say to them, oh, this is good, do it for everyone, we didn't study everyone. We only studied the people for whom we could compare. Maybe the people that we couldn't compare someone else, maybe it's worse for them. Or maybe it's twice as good. Yeah.
But isn't this dangerous though?
No one has been hurt that I'm aware of.
But I meant, the chance for misinterpretation, so you've done something on a subset here, right?
Yes.
And you're saying, well, yes, it's cost effective, no, from cost effective, and it's feasible to do this.
Mhm.
Then you look at this, and clinicians are going to say, this is a good, and I'm going to apply it to everybody. Because I don't, they don't get into the nuts and bolts of all the, the propensity scores and the matching.
Oh, no, yeah.
But they're going to just say, overall, this looks like a good idea or not a good idea.
Yeah, so basically I'm going to have to warn them, if this is someone you would have done CHOP with, our CHOP's a good idea. But if this is someone you wouldn't have done CHOP with, I'm not going to be able to really help you on that. But you're right, there is a danger that you guys are pointing out. Nicole, save me.
So we can make the same argument for clinical trials. For example, it's a very clean population that may not be representative of the real life as well. So, but yet they're making decisions on that very clean population and applying it. So you can use that exact same argument for a clinical trial.
Dr. Unger.
Try matching the controls to the experimental group. You see often, I know you have a larger sample in the experimental, but see how different the sample might end up.
This is clever. So I could take the group that got tossed and see how many significant differences I get with the control group I kept, and we could see. Great idea. I also saw a hand, I think it was you. Yes, excellent. It was nice of you to let her go first, but did you want to add more?
Well, my interpretation of what she said was take the people you tossed and try to find pre-era people.
I can tell you I can't. No, really, that's why they got dropped.
Oh, but so what you did in terms of dropping people was that you took the post-era people and dropped people who wouldn't match the pre-era people. But if you were to instead drop people from the pre-era in order to match those post-era people that you dropped.
Yeah. So let's talk about Venn diagrams. Imagine two circles, and there's some overlap. One's we're just going to assume chalk. You can tell I'm an economist, right? We'll assume chalk. So we have two circles. And good thing it's not dark.
On the podium up here.
On the podium.
Oh.
These aren't candies? They taste a lot like chalk. Okay, so we could call this one free. We could call this one pose. This stuff here is what's in our study. We've been spending an awful lot of time talking about these folks. And I think your excellent suggestion was, what about these folks? What about the pre-people I can't match? Did I understand you right? No.
Well, so didn't we drop people there?
Well, let's see. We started out with 1196 in the pre, and we end up with 1131.
So we dropped a lot more people from the post-era.
Yes.
And,
So I didn't quite draw this right.
Yeah, and a lot of them were older. So say we took the post-era people that we dropped and we compared them to older people from the pre-era, for example.
Mm-hmm. Yeah. This is a great idea. So sensitivity analysis we could use to see how this affects the results. Then maybe we would be less dangerous men and women, and seeing how this affects the results. Speaking of the results. No, we're not going to see results. We're going to vote on the results. How many of you think that this is going to be cost effective? I forgot to ask you, where are you from? So let the record show. Is it being recorded? And how many of you think this is not going to be cost effective?
Define cost effective.
Oh, ouch, that hurts. Okay, so we're going to have to struggle with this. We will definitely struggle with what do we mean by cost effective. Keep in mind, this is a drug that's already been funded. So of course we all think it's cost effective, right? Dave was right. It's not just because he's from Roche. He also knows to trust the government's wisdom. This is not being recorded. He knows to trust that they've made the right thing, but it just never hurts to check, right? So let's just check. The first thing we looked at was survival. And you can fit the laser pointer between the two lines. So in oncology, this means that there does seem to be a benefit. If you look over 3 years, you can see a difference of about 1 month. If you study this over 5 years, you can see a difference of 3 months. Dr. Sander and Dr. Cron have done research showing that depending on how long you study something, the cost effectiveness might change. This may become an issue for us later on, but you can see a difference in survival, which then leads, remember the red pill and the white pill? So you can see a difference in effectiveness. We're using survival because that's what was easy for us using the administrative data that we had. Things like quality of life, we kind of don't collect in administrative data right now. So the next thing was the costs. So the perspective we used was the Ministry of Health, because we kind of thought the Ministry of Health might care about that perspective. We needed to adjust for this incomplete cost data issue. Remember, we had some people who went through our study and didn't do us the favor of dying. This is great for them, but bad for the researchers because it forces us to use incomplete data methods. Those could include things like imputing the data, or we could use censoring methods. And my understanding is that the censoring for costs can sometimes be different from censoring for effect. So we had to figure out the censoring for costs. We looked at 3 years and a 5-year time frame, and we also discounted by 3%. This is a short time period, so the discount rate can probably be discounted. So the first question is, what difference does it make if you use really fancy methods for censoring? Well, if you're in the control group where there's not a lot of censoring, then the really fancy methods don't give you that much of a different estimate. If you ignore the censoring, you get an average cost of $71,000. And if you pay attention to the censoring and you do the fancy methods, you get an average cost of about $71,000. So maybe we can ignore it and we don't have to pay attention to all of those sigma signs. However, if you're looking at the new treatment group where there's more censoring because we had less time to study these folks, you could either get an answer of $79,000 or maybe $89,000. So almost a $10,000 difference. So that's kind of like 14–15% difference. This might make it worthwhile to invest some time in understanding these methods because it changes the estimate of costs. In one case, I'm computing delta cost by looking at the difference in height between this and this. And in the other case, I'm computing delta cost or extra cost by looking at the difference in height between this and that. Seems slightly different to me. So this was worthwhile, and all the blood and tears and pain I inflicted on my staff, or we went through together, might be worthwhile. It might be worthwhile to be able to understand this and use this. Once you've got those costs, you can look at in what silos are they occurring. Are they in hospitalization or in other areas? The colors represent the drugs. So we have the new drug in red and we have usual care in blue. And the shades represent how recent. The things that are really dark are happening in year 1, and the things that are really light are happening in year 5. You can see that the two largest differences happen in the categories of the drug hospitalization. And you can see that the drug looks like it has less hospitalization costs. However, those costs may be supplemented in other areas. So let's take a look at the cost effectiveness. If you look at a 3-year time horizon, the extra cost is $15,000. The extra survival is about 1/10 of a year. If you divide this by that, you get $134,000. Oh yeah, is that cost effective? So if you use a 5-year time horizon, you've got an extra cost of $16,000, and you have extra effect of about 0.3. Divide this by that, and you get $61,000. So can you see how 2 years in time gives you only about $1,000 difference in your estimates of extra costs, but it gives you almost 3 times difference in terms of the delta E or the extra effect. Just imagine we had done 7 years or 9. So it's making me think that there might be a relationship between how long you look, how patient you are, and what you end up finding for the cost effectiveness. So there is a great deal of uncertainty. So we plotted the uncertainty. These are bootstrap replicates. The red is if you look for 3 years, and the blue is if you look for 5 years. And if you look at those clouds, you can see that they're kind of at the same height, but the blue one seems to be more right. Kind of at the same height means they're basically showing you it's the same extra cost. Kind of to the right means that the blue is looking more effective. Blue is our analysis if we look over 5 years. Red is our analysis if we look over 3 years. And these lines here are the mythical Pegasus unicorn willingness to fund, WTF. So if you want an easy way of counting what percentage of the docs are underneath the line, you can make a cost-effectiveness acceptability curve like this. This is if you look at everyone all together. Here is sort of the individual family portrait where we have it broken out by age group. So if you are all ages, that was the one I just showed you, the blue line, but that's composed of different patient subgroups. We broke it out by age, remember, because that's how the ministry funded it, by age. Remember that group they funded last? That's this one that looks the most cost effective. We can see that as you get older, the likelihood that this is cost effective may be a little bit less. So again, this is administrative data, so there may be very important things that we're missing out on. But if you look at the data you have, this is what we see in terms of cost effectiveness by age. I'm about to conclude by putting these results in context, but before I do, are there any questions from Liddy?
Well, I just have one quick question. You mentioned cost effectiveness by age. Is it possible to do a cost effectiveness by disease type?
Totally.
Well?
Yes.
Okay. And then does there exist the opportunity to link administrative license data with clinical charts and things like that? Because I know in other countries with big data, they link the two if you want to look at quality of life in patient-reported measures. I mean, looking at survival is one outcome, but looking at patients, like, while they're being treated, like their outcomes during that process?
Yes, I think this is the next stage. This is the future, is being able, so you can do it with data that aren't perfect, that aren't necessarily what you want. Why not try it with the data you have? You could do it in real time by consenting people, collecting the data you want, and then merging it. Yes, this is definitely the future. For right now, the purpose of this was to show that it was possible. This was not easy to do. But now it might be a whole lot easier and we could do even better. Yes, Ba.
If you have quality of life data,
Yeah, if we had it.
then what would happen to the asset?
So he's asking if we had quality of life data. So you might imagine that this drug has no side effects and actually makes you feel so much better than if you don't have it. In which case we could see not only a length of life difference, but also quality of life difference. It's also possible that might not be the case, in which case that extra life you're seeing might need to be shrunk by the fact that you are having side effects that don't make it as enjoyable as if you had that time without the side effects. So the short answer is I'm not certain, but oftentimes by quality adjusting in cancer, you shrink that extra. But I don't know. I do not know for this case, but it certainly makes me think so. And the idea Vidi has about merging the two data sets would be an easy way to figure this out, especially if there were kiosks that were getting this data collected automatically right now. And if they were linked to quality of life, Nicole, you should really look into that. I think I saw other hands. Yes, Eric, and then Beata.
I'm still bothered by this issue of your control group is not simultaneous with treatment.
Yes, yes.
And I'm not convinced that propensity matching, all these other things, that there's something going on here with the approval of a new drug that it's just not just the effect of the drug, but also has to do with when clinicians have a new tool, they change their clinical decision making about how they treat in a variety of different ways.
And maybe who they treat?
And who they treat and everything else. And so I'm not clear that you have a really adequate control here. And I'm wondering if you could surmise a little bit about which direction that might affect the cost effectiveness that you're looking, because I can see arguments both ways. They could be either enhanced or less than what you're seeing if you did have the simultaneous control group.
I can't do better than what you've done. You're exactly right. I feel, depending on how you feel that change is happening, they're taking on sicker people, then I've got an underestimate maybe. or if they're taking on weller people, or they're doing a better job treating. Here's the thing, if you're not following Eric, imagine my control group was from the 70s. And now I'm comparing the way cancer patients are being treated today. It's possible that other things besides just the drug have changed. So you've got to have the control group close enough in time that the way people are being treated hasn't changed. Too close, and we can't get enough people taking the usual care. Too far away, and it might be something else besides the drug that's causing this change. Eric is talking about something else besides the drug that might be giving us this result.
Or
yes.
so it's correlated with the drug.
Correlated with the drug.
With the drug, and it has to do with something else besides the drug itself.
Yes. Classic.
To
Yes.
address that concern, post the funding of rituximab, were all patients then, was that the new standard of care for every single patient going forward, or were there some patients still considered on CHOP? That's a critical question.
So we're going to leave it as a clinical question. I saw the timekeeper with her hand up.
I guess my comment goes back to what Bob said. So what if you included utilities? And so I think my main issue I'm struggling with is how you can apply willingness to pay thresholds that being as arbitrary as they are,
yes.
but that apply to a cost per quality estimate to a cost per life year. And so implicitly, you kind of assume that a life year, or that the quality of life is one, because you value all the life years you gain, right? So unless the new drug is so much less toxic that it kind of outweighs that, that life gain that you have when it's quality adjusted, whatever. So basically, you're overestimating. I mean, in most cases, you would be quite overestimating the cost effectiveness.
Yeah. So I just want to, this is an excellent point that Dr. Sanders is making. What she's saying is we're looking extra. Someone says, what's the extra I'm getting? About 0.1 of a year is 30 days. But she's saying, and Bob is saying, having cancer isn't as much fun as it seems. And there may be some side effects that make this 30 days extra life really equivalent to, say, 20 days of extra life, but without the side effects. So their quality of life point is shrinking, talking about shrinking the extra effect. So if you take the extra cost and you divide by the extra effect, you get 134. But just imagine this was cut in half. Then this is about 270. So that's what she means by I'm underestimating the delta E in this case. Now, the point about the willingness to pay, I would respond by saying, as economists, I don't think it's our business to be telling people WTF about the willingness to fund. This is why we need to embrace methods, I believe, that allow it to vary. So that we can say, hey, we don't know how much you're willing to pay, but here's the scale. You use it as you see fit. Our goal is to produce information that people find useful. I don't think they want us telling them what to do. That's just my opinion. I could be totally wrong, and they really want me to tell them what to do. So those are the 2 points that Dr. Sander is making, and they're right on, and Bob made it as well. And Nicole, you really need to get on that quality of life thing. Okay, so I'm thinking about concluding, but hopefully we'll have some time for questions after the last couple slides. So we're on to the conclusion. How does this look compared to other studies? Well, we found a couple of other studies that showed larger delta E, the studies that claimed that the drug was more effective than we found, and our study showed that the drug was more costly than others had found. So if cost effectiveness is extra cost divided by extra effect, and our numerator is larger than others, and our denominator is smaller than others, exactly, it's possible that our estimate of cost effectiveness might show that this drug has maybe a little more extra cost per unit of effect than others have said in the literature. Again, I don't know what the truth is. I'm not saying we are right, and I'm not saying they're wrong. What I'm saying is it's possible that, it's possible that you'll get different estimates for what you see in the literature, or it's possible you'll get different estimates for what you see in different points in time when you look at the data that you do have. So I'm going to share with you 2 lesson slides and then open things for questions in the 2 minutes that will remain. So here are the methods, take-home messages from my perspective. It seems to me that doctors don't treat their patients randomly. This was Eric's question about, or point, that Maybe people are treating differently. And this is what I saw when we compared the two groups of patients, the CHOP and the R-CHOP. They differed. We needed to do something to match them. This means, it seems to me, that doctors are not randomly treating people. It also seemed to me that we had to pay attention to methods for censored costs. Because if your data are censored, maybe you should use methods for censoring. It seemed to me it made a difference when we looked at the heights of the blue and the red bars. Last but not least, it seemed to me that time frame mattered. I got a different answer when we looked at it 3 years versus 5 years. And by I mean we. This was a team effort. This was something that took a lot of people a lot of time to do. But it showed that it was possible. It showed that it was feasible to perform real-world cost-effectiveness analysis. Maybe this is something we could build upon. It also showed that cost-effectiveness in the real world could differ for what people thought about when they didn't necessarily have information with this drug on our patients with those types of physicians. So to my way of thinking, it showed that this could be done, although it's not perfect, and it made me a little bit cautious about results coming from RCTs and models. Not because RCTs and models are bad ways of analyzing data, but because of the data themselves. The RCT data may not be representative of the group we're going to pay for when we fund something for all of Ontario, and the models are doing the best they can by going and borrowing data points from wherever they can find. So don't blame the messengers, blame the fact that we don't have the data. But once we do have the data, maybe it wouldn't be so wrong to analyze it using methods like we've seen here today. In the remaining time, if you're interested in cancer, I'd like to encourage you to attend an applied research in cancer control conference coming up in Montreal in May. And I would like to thank everyone, and especially my team, for coming out and supporting me today. Are there any final questions before lunch? Yes, do you hear the before lunch part, right?
Yeah.
Okay, good.
Easy question. So,
Oh, good, easy.
From start to finish to get the results, how long does this real-world evaluation take?
I sure hope this is not being recorded. Okay. Okay, this was not easy, and my answer will not be your answer. At that time in the world, the data lived in CCO that we needed, the data that said who's taking this expensive drug. After moving mountains, the data moved to ISIS.
Sure.
And we analyzed all 13 people who had been identified as taking this drug. And then it occurred to us there might be more than 13 people, because if you're working in a team, they can tell you you've totally messed up. There's more than 13 people. So it took about a year before data were moved. If we factor in a couple maternity leaves and a little bit of uncertainty, I would say it took about 4-ish years.
4 years. So from the time the data was transferred to the time you started analyzing.
No, from the grant was received. From when the grant was received.
So when you got access to the data and the time to finish.
Well, the other issue about this, and I really don't mean to complain, especially when I am being, is that because there isn't a lot of infrastructure invested in this, and we have pioneers in the room who can vouch for this, it's still difficult at that time when this was happening to find people who could do what you needed to do, not only in terms of they had the time, but also in terms of they could actually find someone else's code and run it and understand whether there was an error. So I'm thinking now that we're in the future, things might go a lot faster. So this would be an example of it's the longest time possible and the worst case possible.
Right.
I don't wish it on anyone, but it should be much faster now.
So was this the first time something like this was conducted with ISIS data?
This was the first time that CCO data, which had never left CCO data, went to ISIS. This was also the first time this type of research using these type of methods had been done.
Yes, great.
I'm sorry it took so long.
No,
No, I meant the talk. I didn't mean the research. Yeah.
But ISIS must have done prior studies on using ISIS data, cost effectiveness analysis, with sensors, cost, with survivors. logical like this.
It does, you know, someone should look into that. It could be really important.
I have a question with respect to study. Can I quickly?
Okay. Only if it's quick.
Yes.
And I know Eric had
How many patients survive your 5 years?
How many patients survived my 5 year?
Like in your 5 years, when you looked like the difference in the effect, 3 years, 5 years. How many?
Short answer is I don't know. I would need to check the paper.
Okay.
That's one.
Okay, so the general question is, you've done it with tocilizumab. How often do you think this is feasible to do? If you want to do for a lot of other drugs and a lot of other drug or health interventions, you said all these qualifications you put out, and we had to choose because of this, because of that, and then we had to decide on something. Was this a rare event where the waters came together, you know, in such a way that you could do this, or most of the time they don't come together and you really can't do this?
So Jacqueline bears the scars of many attempts we have made. This, unfortunately, needs a lot of things going for it to happen. This cannot happen by accident. You need to be able in your study to look as long as you need to see an outcome. We had many opportunities for us to have things not work. If we're going to do this, we need to invest in it, and there are certain characteristics that we know very well now can lead to failure. This is not an option for everything in every way.
Okay, with this, I would like to conclude round. Thanks, Jeff. Thanks, or upstairs, or both.
And also, like,
One at a time.
And you know, 1 year later, and you're still in the paperwork.
Yeah, that's exactly right.
I was a bit late.
No, I'm so glad you're here. Can I ask a quick question? Yes.
Usually when we do a regression analysis,
Yes.
we consider time dependent how long.
Yes.
So when it's MASH, we'll be able to consider time.
If you wanted to, you could. We didn't in this because we were just going as simple as possible, but you could if you wanted to.